This document is titled Electrical Safety Student Manual. Note to the learner. This manual describes the hazards of electrical work and basic approaches to working safely. You will learn skills to help you recognize, evaluate, and control electrical hazards. This information will prepare you for additional safety training, such as hands-on exercises and more detailed review of regulations for electrical work. Your employer, co-workers, and community will depend on your expertise. Start your career off right by learning safe practices and developing good safety habits. Safety is a very important part of any job. Do it right from the start. Section 1. Electricity is dangerous. Whenever you work with power tools or on electrical circuits, there is a risk of electrical hazards, especially electric shock. Anyone can be exposed to these hazards at home or at work. Workers are exposed to more hazards because job sites can be cluttered with tools and materials, fast-paced, and open to the weather. Risk is also higher at work because many jobs involve electric power tools. Electrical trade workers must pay special attention to electrical hazards because they work on electrical circuits. Coming in contact with an electrical voltage can cause current to flow through the body, resulting in electrical shock and burns. Serious injury or even death may occur. As a result of energy, electricity is used without much thought about the hazards it can cause. I should say, as a source of energy, electricity is used without much thought about the hazards it can cause. Because electricity is a familiar part of our lives, it is often not treated with enough caution. As a result, an average of one worker is electrocuted on the job every day of every year. Electric shock may cause injury or death. According to the Bureau of Labor Statistics Census of Fatal Occupational Injuries, research files for 1992 to 2005, electrocution is the 5th leading cause of work-related death for 16 to 19-year-olds. After motor vehicle deaths, contact with objects and equipment, workplace homicides, and falls. Electrocution is the cause of 7% of all workplace deaths among young workers aged 16 to 19, causing an average of 10 deaths per year. Electrical work can be deadly if not done safely. This manual will present many topics. There are 4 main types of electrical injuries. Electrocution, which is death due to electrical shock. There is electrical shock, burns, and falls. The dangers of electricity, electrical shock, and the resulting injuries will be discussed. The various electrical hazards will be described. You will learn about the safety model, an important tool for recognizing, evaluating, and controlling hazards. Important definitions and notes are shown in the margins. Practices that will help keep you safe and free of injury are emphasized. To give you an idea of the hazards caused by electricity, case studies about real-life deaths will be described. current, the movement of electrical charge. Voltage. Voltage is a measure of electrical force, which is the EMF, electromotive force, that causes those charges to move. Circuit. A complete path for the flow of current. You will receive a shock if you touch two wires at different voltages at the same time. How is an electrical shock received? An electrical shock is received when electrical current passes through the body. Current will pass through the body in a variety of situations. Whenever two wires are at different voltages, current will pass between them if they are connected. Your body can connect the wires if you touch both of them at the same time. Current will pass through your body. In most household wiring, the black wire and the red wires are at 120 volts. Remember, in many countries, black is live. The black colored insulated wire is designated a live wire. The white wires, in the USA they use white for neutral. The white wires are at 0 volts because they are connected to ground. The connection to ground is often through a conducting ground rod driven into the earth. The connection can also be made through a buried metal water pipe. Now, in older days that was very common, but since in more recent times they no longer practice connecting the earth to the water pipe, because in some cases there was imbalance in the circuit, and that caused somebody having a bath to receive an electrical shock. Remember also, while white is used as neutral in the USA, blue is commonly used as neutral in many other countries. Ground, a physical electrical connection to the earth. Energized, that means live or hot. Similar terms meaning that a voltage is present and can cause a current, so there's a possibility of getting shocked. If you come in contact with an energized black wire and you are also in contact with the neutral, the white wire, current will pass through your body. You will receive an electrical shock. A conductor is a material in which an electrical current moves easily. So common conductors would be copper, which is a material in most cables. You also have aluminum conductors, in many cases used for overhead power lines, and most other metals are also good electrical conductors. Neutral, it means at ground potential or 0 volts because of connection to ground. The black and red wires are usually energized and the white wires are neutral. Metal electrical boxes should be grounded to prevent shocks. If you are in contact with a live wire or any live component of an energized electrical device and also in contact with any ground objects, you will receive a shock. Plumbing is often grounded. Metal electrical boxes and conduit are grounded. Your risk of receiving a shock is greater if you stand in the middle in a puddle of water That can also be the case if you stand on a wet floor, especially barefooted. If you don't even have, but you don't even have to be standing in water to be at risk. Wet clothing, high humidity, and perspiration, meaning sweat, also increase your chance of being electrocuted. Of course, there's always a chance of electrocution even in dry conditions. Now remember, when the skin is wet, the resistance is lower, so the current that flows through it is higher, and higher current means more severe electrical shock. You will receive a shock if you touch a live wire and are grounded at the same time. When a circuit, electrical component, or equipment is energized, a potential shock hazard is present. You can even receive a shock when you are not in contact with an electrical ground. Contact with both live wires of a 240 volt cable will deliver a shock. This type of shock can occur because one live wire may be at positive 120 volt and the other at negative 120 volts during an alternating cycle, a difference of 240 volts. You can also receive a shock from electrical components that are not grounded properly. Even contact with another person who is receiving an electrical shock may cause you to be shocked. This is a case being looked at here. A 30-year-old male electrical technician was helping a company service representative test the voltage regulating unit on a new rolling mill. While the electrical technician went to get the equipment service manual, the service representative opened the panel cover of the voltage regulator's control cabinet in preparation to trace the low voltage wiring in question. The wiring was not color-coded. Color-coded means having the proper colors. In the USA, white for neutral. In many other places, blue for neutral. Green for earth, or you may have green and yellow stripe for earth, and the other colors for live. The service representative climbed onto a nearby cabinet in order to view the wires. The technician returned and began working inside the control cabinet near exposed energized electrical conductors. The technician tugged at the low voltage wire while the service representative tried to identify them from above. Suddenly the representative heard the victim making a gurgling sound and looked down to see the victim shaking as though he were being shocked. Cardiopulmonary resuscitation (CPR) was admitted to the victim. About 10 minutes later, he was pronounced dead almost 2 hours later as a result of his contact with an energized electrical conductor. To prevent an incident like this, employers should take the following steps. Establish proper rules and procedures on how to access electrical control cabinets without getting hurt. Make sure all employees know the importance of de-energizing, that means shutting off electrical systems before performing repairs. Equip voltage regulating equipment with color-coded wiring. Train workers in CPR. Another case. A maintenance man rode 12 feet above the floor on a motorized lift to work on a 277 volt light fixture. He did not turn off the power supply to the lights. He removed the line fuse from the black wire, which he thought was the hot wire, but because of a mistake in installation, it turned out that the white wire was the hot wire. That means the live wire, not the black one. The black wire was neutral. He began to strip the white wire using a wire stripper in his right hand. Electricity passed from the hot white wire to the stripper and then into his hand and through his body, and then to the ground through his left little finger. A co-worker heard a noise and saw the victim lying face up on the lift. She immediately summoned another worker who lowered the platform. CPR was performed, but the maintenance man could not be saved. He was pronounced dead at the scene. You can prevent injuries and deaths by remembering the following points. If you work on an electrical circuit, test to make sure that the circuit is de-energized or shut off. You should, of course, always assume that a conductor is live until you test and verify. And as much as is practicable, never work on live energized circuit. Never attempt to handle any wires or conductors until you are absolutely positive that their electrical supply has been shut off. Be sure to lock out and tag out circuits so they cannot be re-energized. That means you open the circuit and place a lock such as a padlock on it so that no one can close it and energize it. And you place a tag warning anybody coming close by not to try to energize the circuit because somebody is working on it. And the last point here, always assume that a conductor is dangerous. Always assume that a conductor is live. And even when you de-energize the circuit by opening the breaker or the isolator, you must still test the wire to see if it is live. Always test a circuit to make sure it is de-energized before working on it. Summary of section 1. You will receive an electric shock if a part of your body completes an electrical circuit by touching a live wire and an electrical ground, or touching a live wire and another wire at a different voltage. We will look at section 2 in a separate video.